Well, hi, good morning. Thanks so much for spending part of your day with me here while I work on this radio. At this point, I think what might make sense is to check the biasing of the different tubes that are in this radio. When I turn it on, I've noticed a couple of times as I imagine the voltages are rising in the radio, there comes a point where it seems to work better than when it fully warms up and assumably these voltages have arrived at their destination. That suggests to me that there could be some kind of bias problem in the radio, and maybe I can track that down. That's the idea. Now, I haven't made enough observations to really understand this well. Does it happen on AM? Does it happen on FM? Does it happen on both? Does it happen not on AM? I don't know. So I really haven't explored the whole thing. I've just noticed a couple of times. So why not take a few minutes, look at how each tube is biased, where it's getting its grid bias voltage from, and then see if I can't check it, which it can be a little bit tricky checking tube bias voltages a little bit. The act of testing them can throw them off, so the test result isn't valid. And how do you know? It's hard to know for sure. So the starting point here is to look at the schematic and just see how the different tubes are biased. We already know about the output tube. That's biased with the cathode resistor. Let's take a look. Okay, here's the schematic. Let's start with the output tube just to verify. So it has a high wattage cathode resistor here, bypassed with this capacitor. I checked this resistor. Its value was I think 172 instead of 170, and that's absolutely nothing to worry about. I also checked this resistor, which is a high wattage resistor, 3 watt resistor, and it's 1300 ohms, just as it says here. So we know there aren't problems with those resistors. This resistor creates the bias voltage here in the tube between the cathode and the grid here. And it does that by pushing the cathode a little bit positive, and the grid will end up relatively negative. Now, what could be happening here, since I did not measure the grid voltage or make any attempt to do that, is this capacitor here could be leaking some DC voltage. This is common in old radios. This is a very small capacitor. It's probably a mica. Maybe that's what these dots are indicating up here. Or the wings on the one plate. Not quite sure what all is going on here. It looks to me like if you have an electrolytic capacitor, then you'll see a little plus sign on it. Here's one here. And they make one plate white or clear so you can spot it. That's pretty weird. Look at this resistor here. Checkerboard pattern in it. Well, okay, not get distracted now. Lots of little bits of information are hidden away in codes here, and my monkey brain's not figuring them out just yet. So going back to the problem of this capacitor could be leaking some charge. Well, this is interesting. What's this? Variable resistor here. And where's it coming from? Well, it's coming from the output of the speaker. Well, again, a lot of these radios, the engineers go wild on trying to produce exactly the kind of tone they want. And wild is the word for it. And they do all kinds of stuff in here. Far be it from me to sort out. That's probably what most of this is. Exactly what's going on here? R34. And I wonder if this is a front panel control that you would operate like a tone control. Well, maybe we can find out. R34. Let's just stay focused. Bias issues. So there's no. This shouldn't have any kind of bias effect. It's just an alternating current circuit back here. I'm going to guess this is a feedback control. Feedback in these radios is used to correct distortion. It's a very, very powerful effect on distortion. And it's very commonly used. Maybe that's what that is. A technique for providing feedback. I don't know. I'm clued out on what's going on here with this. Okay, on to the next tube. So this tube's grid is here, and you can see it's grounded. That's a cathode, Jim. That's a cathode. The grid's up here. Okay, thanks. So this grid is probably getting its bias from itself. It's probably self-biasing. We have another control here. What are they up to here? TA, TB. What am I clued out? There's no stereo in this, is there? I don't think so. Why the two controls here? Okay, so just a little more I don't understand. That's fine. There's all kinds of stuff I don't understand about this radio yet, and probably never will. You got to keep pressing forward though. So let's track the audio output here now. There's going to be an FM and an AM output. So this is this will be the AM output here. Whoops. It's got to get over to this grid. How's it get to the grid? Grid. It's got to get to this grid rather. How's it get there? Well, it can only get there through here. What's this, just the volume control? Maybe this is just the volume control. What would this be? This looks like a tone control to me because of the capacitors around it. And it looks like the signal gets up there through this switching where you're selecting either the TA or the TB. Tape input, something like that. And you're selecting one of these two. Maybe this is the speakers on. No, I don't know what this is. I don't know what that is. Okay. You're selecting between these two lines. One line goes to the center tab on this. Called the FM. I don't know what to call this. FM. Let's call it the FM coil. So that's going to be audio coming there, because this coil is connected up to these diodes here. This one. Oh, lots of wires here. Well, suffice it to say, one of these two is the FM audio and the other one's the AM audio, I'm pretty sure. And it's selected here on the switch, and then through this weird arrangement somehow gets stuck onto this grid, going through the volume control past the tone control here. What is this guy? This must be an internal adjustment. Maybe done once? I don't know. Don't know what that is. Factory adjustment? I don't know. Okay, sometimes they have tone controls on these radios, like brilliance and weird stuff like that. This one doesn't seem to have anything special at all. Just looks like a treble cut, bass cut type arrangement. So maybe this is the treble cut and this is the bass cut, or something of that sort. That's probably what it is. There's two tone controls anyway, so that would be that and that. Okay. Just figuring out stuff along the way, or coming up with a story that's satisfactory for me to believe. So biasing of this is self-biased. Small capacitor here. This is not a large resistor there. 10. That's got to be an M. 10 megohm. So this will develop a negative voltage and its own bias based on the signals in it. So this is not likely to be wrong. Come over, and also this is very hard to test. Put a ohm meter on here and you'll drain out the charge and get a different pressure reading, different voltage reading. What is this? What is this little thing? There's another one over here. What is that? Very large omega symbol. I don't know what that is. Huh. Okay. More mysteries. So this guy gets his bias. It's on this wire. The DC can get through these coils, through this big resistor, and we get down to this line. Probably connected up here to the grid through some switching. And now if we track this back, I'm sure it's going to go right back to the detector. Here's a huge resistor here, 2 megohm. And we're getting back towards the detector. There we are, the center one here. There's various things engineers do with these detector tubes. Sometimes they use, like there's 3 plates in here. They'll use 1 plate, 1 diode to do the AM detection. They may use the other 2 diodes to do the FM detection, depending upon the style of detector in here. Or they may use 1 to generate the AVC, or they may steal the AVC, automatic volume control voltage. They may steal the AVC from the detector here. Steal some. It doesn't take much, because the amount of current flowing this way is essentially nil or close to it, because of capacitors blocking things, and because the grid, ultimately this gets to a grid. It doesn't go anywhere. That was not the right way, up this way. It doesn't go anywhere. There's no way you can have current flowing from the grid. Well, that's not true. You can get current on the grid for a couple of reasons, but you're not supposed to. So typically no. So very, very high resistance in through here. No current flowing. No drop on this resistor. Look at the one beside it, 3 megohms. That's going down to the grid of the magic eye. This is a whole issue we haven't even looked at yet. So what's happening here is the signal being picked up by the radio. Let's say it's tuned to a radio station. The station is producing a signal through the IF. When it comes out of the IF amplifier string here, it gets detected, which is a fancy way of saying it gets rectified like any AC signal. The half signal can then be used to extract the audio from it. The half signal also produces a DC voltage like any rectifier. And you could throw away the DC voltage and do nothing with it. But clever engineers realize that that negative voltage, or that can be, the diode can be directed to produce a negative voltage, and that negative voltage is handy for operating bias. And the interesting thing is, it's easy as pie. The voltage gets greater when the signal gets stronger. So you have a negative voltage getting bigger on stronger signals. You can then take that voltage, send it back to the grids of these tubes. And these tubes are designed so that as the grid bias gets more negative, they get throttled back. They get weaker, they don't amplify as much. So strong signals get throttled, weak signals fly through. And that's the automatic volume control system. It's based on biasing these first tubes. Sometimes even this one would be part of it. And maybe it isn't here. We didn't really go hunting completely. This biasing system can be operating incorrectly in some way, so it doesn't produce the bias that's expected. And that could be why when you turn the radio on, for a moment it seems to work better than later, because the voltages here are passing through the optimal range. It's a little strange to think they can get extra negative, or I don't know, you have to study all this wire in here and parts and see where they go to really get a grip on this, but there's an awful lot in here. I don't think I'll ever get a full grip on it. So we can check this. We can check this as long as we stay out of the high impedance side of things, and we go over the other side of this 2 megohm resistor here. This is where the voltage is really being developed by the diode in here. We measure it right in here. We'd have to find it. It's on one of the pins coming out of this transformer. Pin number is not written. That wouldn't help me anyway, I don't think. Could be there. Find it anywhere out here if we can find these resistors. Not the easiest thing in the world. Look at all the parts in this radio. We could jump down and use the grid line going to this tube. Now we're off in a different direction here. I'm not sure if we can test it here and make any kind of knowledge of what's going on over there. Okay, testing it. So we won't test this one. It's not really testable directly. Anyway, we can test this. We can test the AVC system. Why don't we look at it that way? We'll check and see what the AVC voltages are doing in this radio. And we can do it in a couple ways. One is back here where the voltage is created, or we can even try right on the grid of one of these tubes. Even though my meter is gonna suck the life out of the AVC here, it's gonna draw the charge down. You know, it's 2 million here. My meter is 10 million. Yeah. Okay, that's the plan. Check the AVC voltage. Find a good place to test it, and check it out. Okay, here we go. Now, we really want to concentrate just on this part of the schematic here. So I'm going to zoom in on it. Okay, and just get it right in the center. This 3 megohm resistor and this 2 megohm resistor, we're trying to find this point. Okay, I've already found the 3, and I think I found the 2. We're going to do a couple of tests here to prove, or observations to prove I'm looking at the right stuff. Okay, so the 3, I believe, is this one right here. It says 3 megohms right on it. It's connected in the right area. This is the second IF can, where it should be. And I believe the 2 is this one, right here, which is heading over to a tube terminal. Now the thing is, just because it's on a tube terminal doesn't mean it's connected to the tube. Some of these terminals are spare on these tubes. I'm going to guess this one is spare. What do we see? We see when I test this with my ohm meter, I don't get anywhere near 2, but it's in a circuit. So I didn't really look closely at the schematic for that aspect of it because it's too complicated. Instead, I just tried to do the visual thing. If this is the 2, it'll say underneath it here where I can't read it. If it's 2, it's tied here, then it's connected to a capacitor, a resistor, and an electrolytic capacitor. Okay, so if we look on the schematic now, and we follow the other side of the 2 here, come up here, we see it's connected to a capacitor, an electrolyte, not electrolytic. Hold the fort here. It's connected to this resistor. It's also connected to this resistor. And it's connected to this. I don't know what this is. This is what? A gap? I don't know what a switch? Not exactly sure what that is. Well, it didn't quite add up. I thought it added up perfectly. So let's just take a look at this table way on the far side here, which I was studying finally. So this is the key to understanding the codes that they've put on the schematic. There's a lot of information coded into the schematic. So for instance, when we look over here at this resistor, we see a plus sign. So if you come down here and you look in the resistors and you see a plus sign, it's a 1/4 watt. So the symbol in the resistor is showing the resistor wattage. But that's not what we're looking at. We're looking at a capacitor. It was a capacitor with wings. Was it not? I've got to find my way around in here again. Here we are. So there's the 2 megohm we come across. It's a capacitor with wings and a dot. And I don't think that's on that table. It's definitely a capacitor. 100 picofarad, 50 nanofarad, resistor 500K, another resistor. Did I not see it right? Well, in the radio. Okay, let's take a look. Coming over picking up a resistor here. I'm just checking for leads I can't see that could be in there. No. So we're connected here to this electrolytic. That's got to be an electrolytic capacitor down in there. You can barely see it on the camera. And maybe this isn't the 2. If I got this backwards, this would be the 2. Hey, this and this are the same wattage. What are the symbols on the schematic? Symbols on this, the same symbol. A plus and a plus. So the same size resistor. So you can't have it this and this. This is a different wattage here. This is a very small wattage. This has to be the 2. Now how else can I prove it? Get some kind of mirror under here. Gee, I used to have a nice dental mirror. Goodness knows where it went. It's long gone. Nice in the sense that it was a plastic, very cheap plastic dental mirror, and you can stick the plastic mirror in here. I don't have that anymore. I don't think I've got anything that's going to reflect, reflect an image of. Oh, that almost did it. I just need a little shinier piece of metal. How about this? Old fingernail file. Get a reflection there? It's reflecting right on this piece of metal. I need some certainty here before I go forward. I need some certainty. I thought I had it. I turned the camera on and the certainty disappeared shortly after that. So I'm going to stop and kind of work this out myself here. Okay. See if I remember to. Okay. So I've got this camera right up close. And you can't see in the camera right now because of what I just did. Duh. Okay, let's do this. Okay, so you're looking through that camera at the reflection. Put a little more light in here. Now, when I look at what I can read of that resistor, I see 10M in reverse. 10M, 10 megohms. Okay, very good. Now we'll look back at the schematic here. 10M. So how does a 10M fit in here? So guess what? Guess what? Come on. there is a 10. There's a 10 in here somewhere. Oh, it's way the heck over yonder. It's way over here somewhere. 10. How? Well, one end of the 10 is to ground. Am I getting confused by? No. Neither end of this is going to ground. It's going to. Oh, look, a 10M. Okay, excellent. This must be. They're all the same wattage in here. So I'm on the wrong end. I go to the other end of the 3 and look there. Okay, other end of the 3 and look there. Okay, now if you just saw a bunch of nonsense on the screen, it's because I didn't edit it properly. When I edit my videos, I'm just cutting out some transitions, some rough transitions that occur all the time, the way I do this. That's all I edit out. Hopefully I spotted these ones and got rid of them. Now what am I doing here? I don't need to look at them. Come on. Pay attention to what you're doing. So we now know this is the 10. So the one I'm looking for, the resistor I'm looking for, is on the other end. Oh, that'll make me want to just jump through the roof there. Okay. So the other end of the 3 is here. But it's definitely not the same wattage. There's something kind of fancy down here. That guy. Looks like a wire. It looks like a, I don't know what that is. Capacitor looks like. So I see a resistor. This thing, which is a capacitor, I believe. That's it. Oh no, there's another wire coming this way. Another resistor down here. Maybe that's the. Maybe that's the 2. 3. Well, it's got to be either this got to be either this one or this one down here. It has to be a 2. This one is heading up into the into all this kind of the RF area. It's kind of a silly thing to say, isn't it? The whole radio is an RF area. And this other one is heading over to a pin on the first transformer. Could be picking up a grid at this point. Is that a 2? Is that a 2 megohm resistor there? Doesn't matter which way you go, I'm trying to find a simple way to sort this out. And everything is a little bit complicated, the right word? I guess so. Okay, so if we go across the 3, let's see what we get. We're not likely to get 3. That's on its way to like 2.5, but it probably is a 3 megohm resistor in a circuit. So if we come across this other way now, we think this is a 2. Well, that's certainly in the range, isn't it? Why is it going a little high? You expect resistors in circuits, if they're correct, to read the correct amount or lower, not higher. So it's possible this resistor has drifted high, gone from 2 to 2.3. That's a what? That's a what? 15%? It's kind of in the range of many of these resistors when they come out of the factory. Okay, so what we're looking for, though, is the place to hook up my voltmeter to measure this voltage. And this would be the place right here. I'm just looking back at the schematic now. Yeah, so that's ahead of the high value resistors, and basically hooked right up to one of the diode plates. And that's almost certainly the AM detector side of things. If you flip to FM, though, I think the picture might change a little bit. This is a good starting point, though. Let's start right here. Okay, so what I want to do, I guess I can leave the radio operating upside down the way it is. Right now, oops, let's get this out of here. So I'm going to want to hook up. I'm either going to want to make contact with that, or put a clip on there. I'm going to put a clip on so I'm not sticking my probe in there. Okay. Just check this quickly, make sure it's good. Yeah. Have you ever been fooled by a bad clip lead? Boy, oh boy, have I gone down some rabbit holes. Get it on the right spot now, Jim. Okay, that's good. These clip leads have a way of kind of wandering around. I like to wiggle them a bit to see, let them go where they want to go. I'm just going to put this right on the voltmeter. The kind of voltage we're expecting here is 5, 10, 15, 20 volts, negative. So we'll set up the meter here, we'll flip it to negative, and we'll set it to 50 volts to start with, and we'll probably reduce it. My plan is to turn it on, play the AM radio, tune around, even noises will be detected because you can hear them coming out of the speaker, they're being detected. And that's going to mean there's a DC voltage being generated. We should see it on here. Okay, I think I'm all ready. This would be the AM here. I'm going to flip it on now. The volume is turned down. I'll turn it up just a little bit. We're plugged in. Nothing else is connected. Wires are tangled. Let's do a little safety thing here. Okay, we're good to go. This is hanging out here. Come back here. So this is hanging out. This has high voltage on it, and basically it's crashing into my gut. Here, should be a little more careful with this, because that could be a surprise that I don't care to have. Okay, just looking for a little plastic bag. Anybody got one? Here's one. Oh, it's full of nails. Yeah, empty plastic bag here in my shop. Comes to me now. It's way too big. Here's one. Once I just dump the stuff out, it's empty. Okay, empty bag. So this is a better idea than just leaving it hanging anyway, because it could short out. It can touch the chassis or anything. Okay, great improvement. We're ready now? We are ready now. So we're watching this meter, expecting it to go up to maybe around here. It's independent of the volume. It doesn't matter about the volume. If you have a signal strength meter on your radio, this is exactly what it's doing. Reading the DC. Did this not come on? 92 volts. Volume's probably too low. No antenna connected, so we need a little more volume here. There it is. Sitting at 0. Is it because I didn't hook up the negative side? No, the negatives. No, grounded on there. This is connected to the voltmeter. Yeah, there's nothing here. Well, maybe. Let's go. There's a little something there. Now we'll tune the radio, and it should go up and down. It's not very much. When this voltage is low, the sensitivity of the radio is high. And we need a signal. I must be at the end of the run here. We need a good strong... Make it look a little more dramatic if I do that. That's not much of a change. 1 volt. And there's that weird tuning thing again. Directional tuning. That's our best signal there. Whoop. There's only one of these sounds. Watch me tune. You hear it? Try this again. Wow, I don't know, boy. That's I forgot about that problem. That's the weirdest thing. I mean, once you get the radio tuned in, you're golden, I guess. Well, this is a really sad show here. Maybe if I put an antenna on it, we'll get a big boost. Okay, I'm just going to use my finger. We don't need to listen to it too much. Well, that made a difference, didn't it? Okay, with my finger as the antenna. Lots of volume, by the way. Finger as the antenna. That's good. We're on the 15 volt scale. It's working right. It's doing the right thing. Okay, now we'll try the same thing on the FM side and see what happens. So we'll flip to FM. Okay, and we'll turn it up. We'll hunt for the hiss. There's no antenna. I will be the antenna. Don't think I'm a very good FM antenna. That's interesting. There's no response from me touching the antenna at all. This guy's not in very good shape. Now I have this antenna and I have its output right here. Just finding something else out. There's really no signal getting through this radio at all. Okay, so I'm just going to touch one lead. It's kind of a dumb thing to do, but I'll do it. It's as if it's not even there. Like you would expect, you know, expect something out of this radio. That's really I think I put my signal generator on the radio earlier and got something out of it, but it was very, very weak. Put both leads on. What happened there? It's me and my antenna. Okay, watching the meter. The weak signal won't produce much anyway. Watching that meter. Nothing happening at all. That's our one station we got. One station, no AVC apparent. I may be looking in the wrong spot. I may have hooked up this meter to a spot that only sees the AVC from the AM side. The FM side could be done quite differently. So I think I need a stronger signal in here to make a little more. So let's turn this guy on. He puts out enough of a signal. We just have to put this close to the antenna. Hook up one wire if we really want to get a blast. Give this guy a moment here to warm up. He's hidden away. This guy here is what I've turned on. Okay, we need to go up to 100. 100. So I'm trying to read the dial here. Where are you, pointer? So 100's right at the top of the dial. Should be picking it up or not. Make a more direct connection here. Bingo. Okay, so I'm going to put a tiny little antenna on the back of this radio. Oh, that was dangerous. What I just touch with both my hands. Shameful. Unnecessary exposure to the shock potential. Okay, so this will be the antenna, just a piece of wire here. That's the transmitter, that's the receiver. Tune this guy. Okay, now that's a fairly good signal. Sounds distorted to me. It's managing to get a signal into the radio. You know, we're operating with... I've been doing this without raising the voltage all the way. Ooh, those weird sounds. This came way up. We're still on FM. Lots of hiss now. This is not moving. Oh, it moved just the tiniest amount. Sound actually sounds pretty good. Let's switch again because I have the voltage low on the radio. What a mistake. We'll hook up this antenna over here again. And we'll say there. So the 100 end, but you go down to the other end of the dial. Things got quiet. That's full volume. Phew. Didn't I pick something up down here? Where's the pointer? Well, didn't pick anything up at all. Did I hook up the right thing? Yeah. Well, I mean, all we're finding out here is the FM side is just incredibly weak still. Works on that. My voltmeter telling me off. That's the 100. No stations coming in. No AVC action at all. A tiny amount of AVC action. A tiny, tiny amount. Let's give it a blast. Right out of this generator. So I'm going to connect the generator right up here. We're going to give it a blast. Okay, now we're blasting a signal in there. Sounds pretty good when you get it tuned right. But that's a blasting signal. That's way beyond what's going to come from an antenna. No AVC action on FM that I can see. The AVC signal is put to the Magic Eye grid, and the Magic Eye responds. What you can see on the front of the radio as you tune in, you know, it's getting stronger or weaker. It'll do that for AM and FM. So the fact that I'm reading it where I'm reading it, it should still respond on here. I think I just covered my covered my mouth when I said that. So I don't know exactly what's happening. What did we find out today? We found out that AVC seems fine on the AM side. FM side, something going on there, because the strong signal being fed in, producing a good volume out of the speaker, is not producing much reaction here. So I either got the meter hooked up in the wrong place, and I'm missing it because of the way I've hooked it up. We can look at the schematic here. It's right up on the screen anyway. Okay, let's look at the schematic. So if you want to get an AVC voltage into the radio, it's got to go on this line, out this way. So it's got to get through here. It's got to be on here. It could get there this way, could it? So we come this way. We're looking more at the output of the discriminator, I think, because we're coming out of the center here. We're going through some filtering and showing up here to be rectified or detected. And that would put the output here. That would show up on the other side. Well, it would be driven directly to the eye, but it would not really make it through these resistors. That's 5 megohms here. Wow, that's hard to say what would happen. Here's 200K plus 300K. It's 500K to ground, 500K on the top here. So you got a signal coming up from this way, a DC signal. You're going to certainly see it on the eye. Well, you're not going to see it on the other side here. I'm pretty sure. So maybe we're seeing totally normal operation, and the AVC really is only effective on the AM side. On the FM side, maybe not, but it will certainly make this eye operate. That's my determination here of what they're doing. How's the audio getting over to the volume control, which I think is here. You have to get into the top. What's this? The top? Oh my God, 300 ohms. So here's the bottom of the volume control through a 300 ohm resistor to ground. That's the bottom. So this is the top. Must be the input side of the volume control. It's got this other attachment here. And if we track that back, it's almost certainly negative feedback. And see, it's coming back. It's going on the output of the output transformer, picking up some of the audio and firing it all the way back, ultimately, into the grid of this tube. And that can compensate for an awful lot of distortion, harmonic distortion. It really improves it, but knocks down the output volume. So you get robbed of some volume, but you get much better sound by doing this negative feedback thing into here. So the audio signal's got to be coming in the top. This looks like a way around a capacitor, a tone control of some sort. So now we're down to here, then we're down to here, then we're into these weird switches here. Maybe these switches operate. You plug something in, and the plug is a switch. I don't know. So back here, where I deduced earlier, this was AM and FM. What happened to the 3 megohm resistor? They're over here. 3 is here. So we're the audio here. Kind of see what they're doing here. The audio is kind of going this way. The DC is heading this way. I'm thinking there's more DC coming in this way when FM is operating. And it's basically, you really can't, it's a bad way of putting it, but can't get through here. This side looks like a ground to the signal coming in this way. So it's either to make a very, very small AVC voltage over on this side, or nothing at all, or whatever it generates is not important. But they want the eye to work. So they figured out how to kind of bypass all this stuff. Take the rectified DC out of here, feed it straight to the eye without switches and all this other stuff. That's why they have a 10 meg here, so you don't get signal going back this way. DC going back this way. It must be a capacitor somewhere there. I'm not sure now. Well, it could be when you have this thing on AM and you have a potential for a voltage to go back this other way. It doesn't matter because of switching and stuff. I don't know. Who knows? So where would we go looking for the FM AVC? We would look for it here, on the other side of the 3 megohm. We would look for it there. Simple as that. Okay, we'll do that. Oh my gosh, hopefully you're seeing, yeah, you're seeing everything I'm seeing. Okay, good. Yeah, so we're going to turn this on. We're going to move this takeoff to the other side of the 3 megohm resistor, where we think we'll see the FM AVC. I left this on, Jim. You're sticking your fingers in there and it's turned on. Yikes, bad boy. So we're going to want to tune in the strong signal. Oh yeah, I don't have it connected now. Okay, we're going to connect it. Too many clip leads here. volume down because it's quite loud. I need another plug. Doggone it. Okay. Strong say, oh, look at the AVC. I didn't even look at it. Let's tune. Wow. So that was on a very low. So 15 volts now, full scale. This gives us a better. So there we are. We're getting 1 volt. And we'd really have to have the eye operating now. The eye in these radios actually serves as an interesting instrument because it's reading the AVC voltage. And if you can interpret it right, it can give you some hints as to what's going on in the radio or not going on in the radio. Well, I think it's all okay. It's as okay as I can determine it to be at this point. Part of what's going on here with me and this radio is I'm learning the radio. So the way I do that is I take on some kind of task like trying to measure the AVC voltage, and along the way I drag through the radio, forced to make observations and forced to sort certain things out and try to get rid of any false notions I have, that kind of stuff. So it's okay to kind of stumble around and rummage around while you're doing this, because part of what you're doing is just getting more and more familiar with this particular radio before you start going in and changing a pile of parts. And the reason for that is because if you make a mistake changing parts, you got to recover from that mistake, and you got to recognize that you've made a mistake too. All these things are not as easy as they sound. So have we made any mistakes? I don't think so far. We got good tubes in here. We got the AM working well. We got FMs producing some AVC. Now that's interesting in itself. Tomorrow what we'll do is we'll try to actually detect and listen to the output of the FM transmitter, FM receiver rather, the tuner box, before it gets into the rest of the radio. We'll try to grab it and have a listen. And that'll tell us if the tuner is producing a good output. Under a very strong signal from the signal generator, yeah, it's getting some output for sure. But regular antenna input seems extremely weak. Okay, that's where we are. A little bit further ahead. Thanks a lot for watching, and carry on tomorrow.